Start. There we go. I think it's recording now. Okay. And then I'll share my screen as well, and hopefully that doesn't take down my computer. Um, all right. Can you see my screen?
I blocked it for a second just because of the fact that yes I can.
Okay, cool. And
Mr.
then
Mr. Trent Reznor has your
yes.
all right.
Uh, wait. Where do you see? Oh, at the in the title bar. Yeah.
Yes. Emacs at Trent Reznor. So
Yeah.
big Nine Inch Nails fan. I can tell. All right. Hey everyone. My name's Ron Batum. This is I guess we are calling this now Lisp Web Dev from scratch. Um, uh, our third episode in this ongoing little series on essentially developing a common Lisp website. Although, as I've been talking probably in at some point, um, it might be different Lisps as we go on. We will see. Today, our main focus is going to be on talking about how do we start up a web server in Common Lisp, and then more importantly, how do we use that web server to simply write a response to a particular request. Okay. Um, to get started, I think it's important for us to start talking about the different types of web servers in Common Lisp. Common Lisp actually is home of many small web servers, if you will. The more popular ones that most people are familiar with, and these are the ones that we're going to be focused on,
Yeah. Like,
are
what's
Hunch and
the?
Toot,
Yeah. Okay. Hunch and toot.
Hunch and Toot, which is spelled HUNCHENTOOT. Okay,
Okay.
and the other one is Clack, which was written by Eitaro Fukamachi, who many of you who's followed the Common Lisp Study group, which is what I also run, um, is famous for writing pretty much Roswell, as well as Caveman 2, which is a web application framework, Ningle, which is another web application framework that's a lot more lighter weight, and a bunch of other libraries that are written inside Common Lisp, many of which I've actually highlighted in various series over the past years. Um, just a quick shout out to Eitaro Fukamachi and all the work that he's actually done in this. Um, Thank you so much for the contributions. Um, Today we're going to talk about a Hunch and Toot a little bit first. I'm briefly going to mention Clack mainly because Clack is more versatile and is actually more performant. But for the purposes of doing like development, Hunch and Toot is good enough to actually get the majority of your requests and responses done. But at some point, when you do create a production Lisp image, it would be useful to use Clack instead. And you shouldn't have to, last time I checked, have to do much in terms of um, changing your code. Which, as we go through this series, we will actually create a more complete website. Um, you don't have to
Okay.
change much of your code in order to actually dispatch and deploy it onto Clack versus Huntington.
Oh yeah. So the way I've been deploying stuff is I already have a virtual machine with Apache set up, and I every time I deploy something new, I just put in another reverse proxy. So um, I have another like top level domain. So I have each.do, and then I have tax.each.do points at one directory, and then uh, and like um, and so I do a bunch of those. So I'm guessing we could do something like that with this hunch and toot. Also, can you?
Yes, you can. And Clack is another thing that you can do that with too. In fact, the production level recommendations now for modern Common Lisp, at least for lack of a better term, modern Common Lisp,
Yeah.
um, is using like Nginx as a reverse proxy, or in your case, Apache, and reaching out to Clack running in a different process altogether. It's not like
Yeah.
though there's no mod. Let's just put it that if you're using Apache, as far as I know, there's no mod. In fact, they suggest that you use like fast CGI with Clack, and that would also give you a pretty decent high performance web server for
Cool.
handling many requests. But
I
I think
tried to set up a Unix pipe file and couldn't quite get that working. I'll I don't know if I care enough. I mean, I'm not serving a whole bunch of people right now, so I think I'll be all right. Could you either shrink your window or bump up your text font size?
shrink my window. Oh, yes, I can shrink my window. How about
That's good.
that? You
That's
good?
legible.
Is it now? How about hey, I did bump it up, but okay. All right. So let's go
Hunch
to
and toot.
Hunch and Toot. Hunch and Toot, and the other one is Clack. Okay.
Cool.
Um, let's go to our REPL. Okay. So for our purposes, we're going to use um.
Oh, okay. So I will bring up a REPL and I'll type in the same thing.
So
What did
we
you
want to
type?
start with running CL project.
Okay. So just in parentheses CL
No,
dash
no, no.
project
Quick load
or
QL quick load CL project.
hold on. Okay.
Now
QL
CL
quick
project,
load. Oh,
yeah,
I see. I see. Wait, hold on. Let me do that. QL quick
quick
load
load. Right. So let me
CL
briefly, before you hit
project.
enter there, let me just
Okay.
do close quotation, close paren. Let me just quickly review, mention to our audience about this. So we never at this point touched base on what Quick Lisp is about, but Quick Lisp is the package manager that we end up using to actually load Lisp libraries into our common Lisp image. I've touched again, AFP, the Atlanta Functional Programming Meetup, has covered this in detail if you guys want to get a more in depth view. I'm just giving you a quick overview on what this is. The quick load command essentially loads up a project that it finds on the main quick Lisp repository that's available, that's public. Um, if you end up misspelling anything, it'll throw up a condition saying that it'll attempt to abort because it can't actually find the project. Very quickly, let's show if you don't know the project name, what you need to do before you run that. Actually, just run that command, and I'm just going to show. I'm going to show what needs to be, what you can do to search for projects very quickly.
Okay.
Yeah,
Dang, look at that. It's downloading so much.
yeah. So okay, so
Okay.
let's say that you want to look for a particular project and you don't
Yeah.
know what's available. You can actually run a command called system ql system apropos. So instead of system dash apropos, yeah. And then if you specify the project name, or some, like, let's say XML or something like that, it'll
Like
give you
this?
all the, yeah. If you and you hit enter, it'll give you all the projects that are named after XML that are associated with that particular topic, and you can go through all of them. And then
Cool.
so searching is pretty simple. You don't actually have to go to any sort of third-party site to actually go and look up the stuff. It's
Very
pretty quick,
fast.
and it's very fast.
What
Exactly.
is FXML?
Let's not get into all the different stuff right now. Let's
All right.
there's all there's too many libraries here.
Oh, I saw
Not
darks.
enough time. Let's just put it that. Let's put that
Okay.
way. Okay. Okay.
All right. So after I did that, did that like put a bunch of files in the current directory? No, it did not.
No, it did not. It actually loads it into your Lisp REPL. Okay.
Okay.
So the main reason we want to do this, just for starters, okay, is CL project is your project generator. Okay. We're not. we're not going to try and use like an external thing to actually generate the project skeleton for us. We're actually
Okay.
going to go ahead and just use CL project to do that for us. And the way you do that is you do CL project, make project. Okay. You specify the path. And now, for folks who aren't familiar with common Lisp path names, which I'm assuming most of the folks listening to this stream aren't, common Lisp path names start with a hash p because the hash p is
Is,
specifying to the Lisp reader. That's what's called a reader macro that's
is it
going
a
to
capital
convert
P?
this. Yeah, capital P.
Okay.
Um, that the following string is representing a path name, and there's a huge thing about path names that we can go through. For right now, just know that path names are basically hash p followed by a string with a relative path, okay,
Okay.
to the location that you want to actually go and create the project in. One thing to
Okay.
note, um, directories, if you want to create directories, you have to end, which I'm going to just show you in this example, sample web app, okay? You must actually put that trailing um, uh,
Slash.
slash. Yeah, thank you. I had a brain fart there. That trailing slash, because otherwise it's going to treat that path as a file. In this case, make project is pretty smart to actually recognize it as being a directory and it doesn't exist because mostly make project will create directories. But I don't, you shouldn't assume that for every API that they're going to go through that handle, just mainly because of the fact that some do not. And you will encounter this, especially when you're dealing with older libraries that have been stable but haven't necessarily been extended to handle all the different cases of path name handling. All right.
Wait, sorry.
So
So the difference between if you leave the slash off and on
is the
is
difference between file directory.
it'll make a file named sample web app, I
It
guess.
will not in the case of make project. Other in the case of I think with open file or one of the standard library functions, it will attempt to like read or write a file
I see.
and
Okay.
it'll complain. So
And then should I hit enter on the way that it
no,
is right now?
not just yet because we
Okay.
haven't finished the actual command. Okay. So
Okay.
the next thing that we need to do is add the dependencies that we want.
Okay.
So we need to add. So we do colon depends on, and we're creating a list. I'm using the shorthand notation for list, which is apostrophe open paren. And then I'm going to add to this the following dependencies. Mainly, we're going to do Hunch and Toot for right now, and Alexandria. Okay. Alexandria is a nice utility library that you may want to just keep at your disposal all the time. Now, additionally, you want to
Wait,
add some metadata to this.
are those strings?
Yeah, they're strings. So, additionally, you want to add some metadata to this. So, the main things that you want to add is the name of the project, which I'm calling sample app, okay, and a description. This is actually what's used by Quick Lisp for you to do quick apropos tests to see what's available. Um, so, and some other utilities actually use this to actually give you some better diagnostics and, you know, licensing because uh, make project actually gives you a whole bunch of options that we're not actually going through here. The main three that we need to do that we need to handle is depends on name and description. Once you have provided those three, you can hit enter and you'll see your sample project get generated. All right. Um, which is not going to show up here because I forgot to add the folder. Let me Um, add new folder. Let me see if I can open up file, open folder. Thank you.
And does
And
the
let's
prompt that I'm
do
working
this.
with right now, does it like check uh whether there's a complete expression? It probably does. Hold on, let me try.
Does the prompt working with right now? Say that again.
My computer's choking. Um it looks like it does. It
Hold on. Let me take a look at what you know that it does not.
uh maybe that's Emacs then.
Yeah. This is basically in Sylvester, especially you're using Spacemax, yeah? Yes?
Yeah.
Yeah, with Spacemax, I think it will use I think by default actually the layer automatically opens up smart parens.
Yeah,
So
I
it
just
should
was wrestling with that.
yeah.
Smart parens was being frustrating.
Yeah.
It creates a readme.org and a readme.markdown. Interesting.
So let me explain these the as most Emacs users know, the .org is an org mode file. The
Uh-huh.
.markdown is has its name
Markdown.
right. It's a markdown file, right?
Not a markup file.
GitHub up until recently only dealt with markdown, all right? But I think in recent years it also reads in org mode files as markdown too. There's a way to do it.
It'll
Um,
render org mode files. I didn't know that was a recent thing. Maybe I have been
So GitHub
maybe
has been
that's
around for a very long time. All right, it's at least was it 2000? I think it came out in 2007 or 2008, right around the time that Git became popular. GitHub shortly came thereafter. Don't remember. It's been 15. It's at least 15 years old, right
it's pretty
before
old.
Microsoft purchased. Okay. Org mode, although it was around, not very many people kind of settled on using it for various tasks and various things. So a lot more people adopted Markdown as default approach to doing stuff.
Yeah, that's
Um,
actually why I stopped using one of the online Git repos. Is they didn't have very good, or that's part of why they didn't have very good org mode display.
right.
Git actually has pretty good, so I'm starting to move stuff over to them. And when I make new stuff, I'm using Gitea, gitea.com.
gitea.com. Okay, gittee.com. Okay, got it. All right, I should make a mental note of that. So this is kind of one of the reasons why, though. Fukamachi is a little forward thinking in that. Um, if you look at a lot of his projects,
Yeah,
the CL project generator kind of had this as soon as he thought of actually creating a successor to Quick Project, which was the default project generator that a lot of folks used before um, Fukamachi took it upon himself to write a better um, unit testing framework above outside of 5 a.m. called Rove, and then he made a successor to that called Prove. So all this stuff that you're seeing here is going to use a lot of his infrastructure.
yeah. I see.
Um,
There's already a test file. That's pretty cool. Are you
yeah.
looking
So
at my screen? Do you see
yes, we
like what
are
I'm
looking.
typing and stuff?
I,
Did
I'm
I
I, I'm looking at your screen.
did I type Fukumachi correctly?
Yes, you did.
Is that his family name or his given name?
That's his
And
family name. His first
what's
name
it,
is Ataro, but if you want to look up his stuff, I believe his GitHub is
like
actually
this?
github.com/Fukamachi, which is
Ataro?
why I always use his
Okay.
last name because that's the easiest way to get a hold of his work. Hold on, did I spell it right? Now I'm wondering if I spelled it wrong. Ka- Yeah, sorry, it's Fuka, not Fuku.
Fukamachi.
Yeah,
Cool.
yeah. So you can get all of his
Oh,
stuff.
Eitaru, Eitaro. Cool.
Eitaro.
There he is.
Yes.
That's cool.
Eitaro Fukamachi. In the flesh. In the flesh.
Um, I'll be right back. I'll still be able to hear you, but I put some stuff in the oven. I gotta go get it out.
Okay, that's fine. Go for it. And while he's doing that, I'm going to talk to you folks about some more stuff that in our project. Okay, so if we go to the sample web app, which you can see here, we have a couple things. We have has Mr. Mr. Watson has kind of brought up. We have a test file and we don't have this. Now, you may notice for folks who are using the Alive plugin like I am using in Visual Studio Code that initially when you open up this file into test file that you see a bunch of red stuff. That is actually because right now our quick Lisp REPL, our Lisp REPL, which is currently running SBCL, it does not actually have the project that we've created loaded into the memory. So we have to actually load that. So let's see how we could do this in um, uh, our our um, this is actually for some reason didn't actually generate what I needed it to do. Actually, let's see something here. If I do this, this is fine. Load sample web. We could just do a quick load. Okay. So the first time we run this, okay, we have to do a QL quick load. There's two ways of actually loading this stuff into the project. I believe using Alive. In Alive, we can actually load it using the command palette an ASDIF system, okay? And we just need to specify, as long as it's a package that's in the registry, it will be able to take care of it. So if I just say sample web app, we can actually go ahead and do sample web app. So let's actually see if I could do a live restart. Clearing line results. Let's do refresh ASDIF systems, then load additive systems. Let's see if we can do this. And let's go to our common Lisp thing here. No, that's right. Where is our Alive? Cancel. This is our main branch. Visualize commits on the con. Okay. I'm going to take a mental note for myself, folks, because it looks like there isn't necessarily a good, clean way of like restarting your Lisp REPL. Let's see. Let me just do one quick section here. Hive common Lisp restart Lisp. Okay, let me do one thing here.
Okay, I'm back.
Okay, great. Um, so I just did a quick load of the project that we created. So this has been loaded, and I'm showing them that in a live you can actually use load as diff system, and as long as the asdiff registry, which is the registry of all packages and past two packages, has been appropriately updated. Which, if you're using Roswell, which go back to our previous two episodes, we've actually introduced Roswell. It should be set up correctly, the ASDIF central registry. You should be able to just search for your particular new project that you created, and it'll actually just load it. Okay.
Okay. Should I
Um,
open up uh, one of these files then?
Yes, let's just open up main.lisp in
Okay.
source. Okay. We won't necessarily touch base about writing tests right now today, just because of the fact that this is going to be a hello world kind of like situation. But this we will eventually start doing proper development and have to write tests, and at which point we will touch base on Rove, which is the easier thing to use for it. I will introduce, we could introduce other unit testing stuff, but I don't think that's currently necessary for the kind of,
Top quality comment right here. Blah blah blah.
yes, that's a high quality comment that they always write in there.
Uh, okay, so then, yeah, actually, so that was one of the things that I wanted to do is get to the point where I could send a request and get a response of any
Right.
kind.
So we need
And
to
for
first write a
tradition, the
handler.
request could be hello world.
So I think the first thing that we need to do in the hunch and toot space, we're going to first write a handler, okay, and then we will uh, talk about how one might extend this to doing say uh, creating a more robust web service that you could just curl. All right, because one thing about Hunch and Toot that I'm going to tell to you and the
Yeah.
folks out there, um, it's actually pretty complete in terms of its implementation of HTTP 1.1, which obviously been superseded by newer versions of the HTTP standard. So for all basic HTTP needs, Hunch and Toot is the way to go. I don't know in terms of using it for production as to what its support is for various things like persistent cookies, session management, how it handles uh, server-side events, which is a big thing now for a lot of modern web development. Um, those are stuff that I've never tested with Hunch and Toot.
Okay.
We're not at the point where we could talk about it. So, but I want to address that up front so I don't hear folks in the comments say, "Oh, you're giving us an outdate." It's not outdated. For all
Yeah, let's
basic
just.
development, it actually is complete. It's just hasn't I don't know what the support is for those because I haven't actually tried actually using it for those particular purposes. Okay, so let's just go and deal with the basic piece here, which is let's define our. Let's go ahead and define our actual handler. All right. Um, the first thing to do is naturally we need to start our web server. Okay, this is going to be running in the background. I'm going to go ahead and throw this into a separate Lisp direct get
File.
file, just mainly because of the fact that we're going to be typing this a lot, and more importantly, we need to keep track of the handle. All right. Now, I'm not putting this as part of the actual project ASD file. Now, for folks who want to know what that is, earlier I've introduced you to this file here. This ASD file is basically, or think of this like your solution. It's the setup of your project, what dependencies it has, and the the test
Oh,
directory. All right. When you load, when you do a quick load, okay, of your project and you say sample web application, what it's doing is it's looking for this ASD file, which is defining the system to load into the Lisp image, and it will load it. Okay.
gotcha.
Additionally, it registers certain operations that they call system operations or operate on systems in ASDF parlance that allows you to essentially use ASDF as a CI system while you are developing inside your running Lisp image. So like this test op here, that hooks into ASDF's run tests command. So it doesn't have to look for the test directory. All right. Which is nice because it then does is when it runs the test operation, it goes and looks for this performance command here, which will ultimately tell it to run rove, which has this function called
Gotcha.
run to run all the tests. Okay,
Cool.
so now you have a single command that basically goes through and you know does everything. You don't have to necessarily know all the commands for all the libraries that you use. Okay,
Yeah, that makes sense.
makes things a lot nice and easy.
All
All
right.
right,
Let's make a something that'll respond to an HTTP request.
right. So the first thing we're gonna do is make a web server. Okay, I'm keeping track of the handle. Okay, for this purpose. So when you run Hunch and Toot, for example, and you do, I believe it's called make server. No, it's called start. Okay, start takes in an acceptor class, and actually, let's do it this way. Let's make the instance on the acceptor class. Okay, this acceptor class basically is you could think of it as just a whittled down web server. Or sorry, it's actually a whittled down server with like threads to handle web applications. So like this easier acceptor does I believe each request is effectively it's in its own thread. Okay,
Cool.
so it's concurrent, but what you need to do is provide it a port. So let's go ahead and call this 8000. Okay, so let's go ahead and load this guy. Okay. Oh wait, sorry.
I'm gonna do 8003 because I know that I have stuff on 8000 and maybe 1 and 2,
Okay, let's go ahead and do that then, just so that we have
or I did
8003.
recently.
Okay. So now the first thing is to start the web server. Okay. And to start the web server, it's Hunch and Shoot start, and then you provide the acceptor that we have to do this. Now, a quick note for folks just joining us or who's already kind of getting like crazy questions about our naming schemes. Why are the earmuffs on web server? This is a common Lisp practice to provide um, affordances using the user interface parlance. Okay, some way of knowing that you're dealing with a global variable. Web server here is a global variable. That means every function that's defined in the Lisp image will be able to get access to the web server. Um,
Do I need to
it's
do at the top something like include Hunch and Toot?
here for this purposes, I kind of assumed that you loaded the sample project, but let's go ahead and load the sample web project here. And that will automatically load Hunch and Toot because we're going to be using the sample project anyway to like to actually hold our code. All right.
Okay.
Um, at some point, we're going to eventually move this around into a deployment script that in the main.lisp, it will actually start our application, our web application. Okay. Now this will be the only web application in this web server because that's how a lot of Lisp web apps using Hunchintoot are written. It's not a web server that holds different applications. It's a Lisp image that holds a web server that hosts a specific application. Okay,
Yeah,
so
that sounds
everything is
like
nice packaged.
the stuff that I've deployed behind using the reverse proxy. Each one is its own server, and then Apache routes requests to them based on which top level, like, is it tax.each.do or brb.each.do or bingo.each.do?
Yeah, but are you using so what are you using in terms of your application development on that side in the reverse proxy? Are you using Python or
Um, I have so each one of those has a front end and a back end. One of them at least is using Flask. One of them is using Express. Um, Probably
okay.
more than one. I actually don't remember exactly which ones are using what, but a combination of Flask and Express and Clojure HTTP kit, I think, is what I'm using for that one
Okay.
for the bingo. That one I remember that that's the Clojure one. And then reagent for the front end on that one. Anyway, uh, the reverse proxy is looking at which top level thing you're doing, and then it's sending it off to a different port. And then so there's like a
No,
bunch of different web
so
servers
so
running
I
at
understand
the
the
same time.
reverse proxy piece at least if I
Oh,
remember
I'm.
correctly.
It sounded like that was what was going on with the common Lisp, like
Yes, that's exactly what it's
the
doing. It's
the
it's the
usual thing
same.
to do. Yeah.
It's the same exact design.
Cool.
So in a it will effectively work with a reverse proxy. All right. Um, uh, the reverse proxy, um,
So we
there
make it
is
work on this port. In this case, we're gonna do 8003, and then it'll be up to Apache or Nginx or whatever
that's
to
right.
make sure that incoming traffic on port 80 gets directed to the local
Right. That is
thing
correct.
accepting stuff on 8003,
N-
and then
Yeah.
also going back the other direction.
Right.
The response from this
The
thing.
response
Okay,
from
so
the web
then
server is going to be done. Right.
cool. So then I think is
So
this
if
all
we
that we
start
need to
this
do,
guy
or do we
up,
need to like yeah, okay.
once you start this
Oop,
guy, um, this is um,
what?
this is going to work out of the box in terms of that it will be able to provide you a simple if we go into a terminal here and we
Yeah,
do a
so
curl
I'm in Roswell.
localhost 8003 and it will Hunchintoot's going to respond with a file a 404 because we haven't actually written a handler yet, right? So but it tells us that the web server is working. Okay, so now
Wait, so how do I run this? So I'm in the
yeah.
directory
So are
where
you
where
in
the
Slime right now? So did you start
no,
the web server?
this is uh bash.
No, I know you're in Bash, but I'm saying did you start
Oh,
the web server in Slime though?
no.
Did you actually run Hunchintoot :start web server?
No.
Yeah, do a space MCF, I think it's called, to actually get that to compile in wait, do you have a Slime REPL open? No, you don't. Okay. Fire up
I don't?
Slime. Do
Thought I did.
space M.
Yeah, I do. I have a
Oh,
slime REPL.
you do? Oh, you
Yeah,
do. Okay.
space MCF
F.
looks like it'll do it.
Yep.
Compile
Defun.
defun? Don't I want to
Yeah.
do file?
No, no. MCF is a Slime compile defun.
Okay.
I think that's what you want to do, right?
I would think that I want to run the whole
Compile
file.
file. Why does it say
Yeah,
compile
Hunchintoot does
file?
not exist.
Oh, you didn't. Did you load you loaded Hunchintoot say your web app, didn't you?
No, I didn't.
Oh,
I didn't do
you
it.
didn't.
I don't
Yeah,
know.
okay.
what I'm
Run
supposed to
line
do.
two.
So I've typed out all of this.
Yeah. Okay, so do
Okay.
this. Very simple. Very good.
Yeah.
Highlight everything. And folks watching, this is the exact same command you could run if you're running Space Max.
Yeah.
Space MCR.
Compile region.
Yes.
I see. Nope,
Boom.
didn't like it.
102 did not exist. What do you mean 102 did not exist? Did you run? Okay, run quick load sample web app first. Just that line two. Line two should work. It should load your. Yeah. Okay.
I think that
Did
worked.
that
I did
load it? So
Control X,
open up
Control E.
You could do Control X, Control C, I think, because that's slime specific.
It's saying Hunch and Toot does not exist when I do
No,
that.
did you run the quick load? Run the line
This one
two first.
I did, yeah. Wait, hold on. Let me bring up this, and then it looks.
Yeah, it says that it's loaded. So
Yeah, I'm loading it over and over again.
yeah, if you loaded it several times, I mean, it doesn't matter how many times you load it. It should be there. You could even try Hunch and Toot in here. Like try make instance Hunch and Toot easy accept. Just copy that line and you can see that it will work in your REPL.
Oh,
So why is it saying that it can't
all
do it?
right.
That means there's a
It
disconnect between your.
it worked just now. I'm not really sure. Maybe I didn't actually run this,
Okay.
even though I thought I did. Anyway, let me try
So
that.
say
Okay.
MCF. So MC.
Uh, space M. The shortcut for that is just comma, and then C for compile, and then C again for compile the entire file. But I just ran this. It looks like it's running on port
No, you're
8003.
not you're not running it. You just created the object. The web server hasn't
Uh,
started yet.
oh, okay.
So you need to start the web server.
Uh,
Hold on.
acceptor is already listening. Yeah, that's what I thought.
Oh,
Okay.
really? Okay.
Yeah.
So then you did it. So do one. Just do one to abort to his slime's top level. Okay.
Okay.
That's
And
fine.
then I'll go. Uh,
To shell. Yeah. 3. And then you got a 404 not found.
cool.
So this is telling you that it's the web server is running, but that's because we haven't actually written anything yet.
Cool.
Okay. So the next thing that we want to quickly do is create a handler function. Okay. This is Hunch and Toot parlance, and many parlances for web servers that for every request,
You
as
got a
most
minute.
people know, that's attached to a URL. That URL is attached to something called a handler function, so that when that URL is routed in, the web server knows how to essentially handle that URL and dispatch it to the appropriate handler. All right, whether that be another web server, or if you're dealing with some higher level web server like Apache that's being acted like a proxy server, or whatnot. But in Hunch and Toot's case, this is just going to be define easy handler. All right, because we're using an easy acceptor, we're going to do define easy handler. All right, so let's go ahead and do a simple one, which is going to deal with um, just saying hello to a person. Okay, this is your standard greeting. Okay, this is straight from Hunch and Toot's documentation because I like this particular code example to explain. But basically, what this does is it defines a easy handler by using, as the name indicates, define easy handler. You specify a function name. Okay, so this is a little bit screwy for some folks who aren't used to this. So in Common Lisp, you can actually either do defun function name open paren args and then code. Okay, so this is what you standardly use in Common Lisp. Okay, but in Hunch and Toot in this macro that we're seeing here, what it's actually using is it's registering this function named sayo with the following URI. Now, I can show you the macro expansion, but I don't want to overwhelm most folks here today. we could talk about it after we actually register this handler, but
Yeah, you're
just
actually over time just a little bit, so
huh?
you're over time a little bit, like over an hour.
No, no, that's fine. We're okay. I have plenty of are you all, do you need to go?
Yeah.
Oh, okay. Very quickly, uh, say yo, we'll take in a URI slash yo with the name, and then we have our standard way of you have to specify the content type in the response. So Hunchitude has this thing called content type star. You're specifying it to text plain, and then we can go ahead and run this guy, and we'll have a name. So let's go quickly, just with the 5 seconds that we have. Register this this handler, all right?
Okay.
And then when we run curl and we do yo and we specify name Dave, all right? Wait, did I spell that right? Uh, wait,
Oop.
um, no matches
Hey.
found.
Cool.
We got K question name Dave. Oh shoot, sorry, Dave. No matches on yo question mark. So it's not actually handling the curl request to Dave. Let me
Mine
just
is.
oh, yours is. Okay, that's weird. Why mine is not. Did I
Oh,
actually
oh,
handle
I
it?
didn't do that. Let me try that out.
Hey, yo actually works, which will give you yo, but you know, we want to actually specify a question mark on that. Let me actually run this in the web browser. This might actually work with the web browser. Localhost 8003 yo question mark
Oh yeah, mine
name
works.
name equals Dave. Yeah, it's because of curl not handling query strings.
It might be the the shell mangling the question mark. Try
Yeah,
putting
exactly.
quotes
That's what I'm
around.
thinking. Yeah, it might be the shell mangling it.
Try putting
Um,
quotes around the URL. So from HTTP to just after Dave.
okay. Yeah, we can do that. Yeah. Okay, that worked.
Yeah,
Nice.
that
Okay,
makes sense.
that makes sense.
Oh yeah, I do.
Um. Okay, so now
Interesting.
we so sorry we went a little over today, but we basically have a web server, we have an
Woohoo!
easy handler, we have a text plane, we're golden. Next time we're gonna talk about adding a web application framework to this piece, so we can start handling things like JavaScript. Well, we'll we'll start talking about our application and how do
I'm
we yeah.
I'm a little bit curious. Maybe I'll save this for next time. Yeah, I'm curious how this is tied to this. Like, how does it?
How is hold on.
How is the define easy handler
Yes.
tied to the web server
Oh,
that we made
that
earlier?
excellent. That is
I don't see. Like, I
um
would expect one of the arguments to easy handler to be the web server, maybe.
right. So the way it gets handled is in the macro expansion of this.
Yeah.
We'd have to actually expand the macro. Um, and the way we do that is expand
We don't
macro
have to
expansion.
actually do that right now.
Yeah.
I'll just take
Just
your word
yeah.
for it.
Yeah, it's
Oh,
in the macro expansion. You can go and look up how the macro expands. It
okay.
just figures out what is currently running that is of instance easy acceptor, and it
Gotcha.
attaches it.
Okay.
All right. So yeah, that's how that all works. Yeah,
Cool.
cool.
All right.
All right. I
See
will
you
see you
next
guys
Friday.
next week.
Yeah.
I appreciate you guys for joining us. And yeah.
All right.
Thank you.
Later.
See ya. Bye.